Hello. In this video I will look at standard deviation. Standard deviation is a measure of dispersion or a measure of spread. We're going to measure how spread out data is. We're going to look at this by considering our 5 dogs and their height measured to their shoulder. Here's the data in a table. I've noted some important things over here. I've noted that n, which is always our number of data, in this case is 5. I have 5 dogs. I have 5 heights. I've noticed this symbol. This symbol means to sum or add up the data. I have the mean. Well, this is the sum of the data, represented here by x, divided by n, which, as I said, is the number of data. We'll come back and look at variance and standard deviation as we work through this example. I also have this row to represent totals of the columns when I need them. First of all, I'm going to calculate the mean heights of my dogs. I sum this column. The sum of that column is 1,960. To calculate the mean, I take that total and I divide it by n, in this case 5. The answer is 392. I'm going to mark that value on my graph. So the yellow line marks the mean 392. I'm going to fill out this column with that average height for each dog. Do notice that our data is represented by x. Our average height is represented by x bar. And in this column, I'm going to record the difference. That's x, my data, minus x bar, my mean. I'm going to record the difference between my data and the mean, x and x bar. I'm actually finding the distance between my mean and the height of the dog in each case. So let me record those differences. Here I am doing 600 minus 390, which is 208. I do 460 minus 390, that's 68. I do 180 minus 392. And we notice in this case it's a negative value. That's our smallest dog. It's smaller than the mean, so we're recording this distance here, which is a negative value. 420 minus 392 is 28, and 300 minus 392 is minus 92. Or we might like to think about the average of these differences. But let's try and do that. If we add up this column, we actually get 0. And that's no help at all. That comes out of the way the average was calculated. The average was calculated by sharing all the heights equally between our 5 dogs. So when we look at the differences, some are greater than, some are less than our mean, and when we sum them up, we get 0. So in order to overcome this and still try and look at an average difference, we're going to square each of the differences. We're going to take that difference and square it. So we're going to do 208 squared, and that gives me 43264. I'm going to carry on and do that with each of these values. When I square a negative value, I always get a positive value. Remembering a negative value multiplied by itself gives me a positive value. So these are all positive values, and when I total them, I will get a value. That's the total, 102,080. Now I'm going to take a look here at variance. Now variance is the sum of those differences. I need a bar there to represent my mean. The sum of the differences squared divided by our n. So here I'm going to represent variance. Now, rather than rewrite that word, I'll show you that the symbol for variance that's a lowercase sigma squared. So here, my variance is going to equal that value, the sum of all the differences squared, divided by 5. And the answer to that is 20416. Now, that's not my standard deviation. My standard deviation, I've noted here, is in fact the square root of that variance. And the symbol for standard deviation then is just the lowercase sigma. So here, taking the square root of the value for my variance, I will see that the standard deviation here is 143. Now I have rounded that to the nearest value. That's all very well. We have a number for our standard deviation. But what does that mean? What does it tell us? So here I've recorded our mean, it was 392, and our standard deviation, 143. Now we can use standard deviation to compare two sets of data. A larger number will mean the data is more spread out, and a smaller number will mean the data is less spread out. So we can compare data using the standard deviation. We also have the idea of one standard deviation from the mean. This is when we have the mean and we add the standard deviation. And we have the mean and we subtract the standard deviation. This is written with a plus minus sign. So we could write it as the mean, x bar, plus minus the standard deviation, represented by the lowercase sigma. So this symbol means to do two sums, the mean plus the standard deviation and the mean minus the standard deviation. I'm going to calculate those numbers beneath. So we have 392. We add on our standard deviation, 143, and our answer is 535. Also, I take the mean, 392, and I subtract the standard deviation, 143, and this gives me the result, 249. This is going to give me a band on my graph. Let me show you. So it gives me a band which looks something like this. This is my mean line, and that's the value of the mean minus the standard deviation, and that's the value plus the standard deviation. This band might contain what I would call normally height dogs. They're neither unusually large or unusually small. The dogs outside of this range might be considered unusually small or unusually large. So this is another way we use the standard deviation, and this will be explored more when we look at the normal distribution. That's the end of this video.